Can heat sinks extend the life of old chips? The consensus opinion in the retro community seems to be that there is no solid proof that heat sinks increase the lifespan of old chips. On the other hand, heat sinks certainly don't shorten their lifespan and may still have benefits. My theory on heat sinks is as follows. Higher temperatures speed up chemical reactions and put more stress on materials. In general, most things wear out faster with higher temperatures. Higher temperatures mean higher stresses in the chip materials. Higher stresses lead to a shorter lifespan. This can be seen by looking at this graph of a material fatigue process. Decreasing the peak temperature should decrease the peak stress and therefore theoretically increase the lifespan of a given part of the chip. Perhaps the benefits of adding a heatsink are vanishingly small, but it makes me feel better knowing that I did something. So how effective is a given heatsink? Two types of heatsinks were tested. A square copper heatsink by DF Robot and a larger aluminum heatsink. The aluminum heatsink material was advertised for use on LED lighting. The bottom surfaces of the aluminum heatsinks were polished using 400 grit sandpaper and mineral oil to remove extrusion marks and improve the overall surface finish. The bottom of the copper heatsink appeared smooth enough. A smoother surface will help transfer heat from the chip to the sink. Arctic MX4 was used for a thermal compound. Only a small amount of this is needed to take up the space between two flat surfaces, so this tiny syringe will last me for a while. It is important to note that MX4 is not an adhesive. There is enough of a suction effect to hold the heatsink in place. I find this works so long as the computer isn't picked up and moved around very much. Every so often I check on the heatsinks to make sure they are still in place. The DF Robot heatsinks come with double-sided thermal tape, but that was not used in this case. Time was measured using this wall-powered retro clock. It makes a nice humming sound. A chromium-aluminum thermocouple read by a multimeter was used to measure temperature to the nearest degree Celsius. The thermocouple was attached to the center of the chip's bottom using tape. The U1 MOS 6526R4 CIA chip installed in a Commodore 64 was the subject of this experiment. These chips run at low temperatures relative to others in the computer. Replacements are available, so it seemed like a good place to start as opposed to the higher temperature MOS 6567 VIC-2 chip, which is harder to replace. The results for the aluminum heatsink show that a temperature rise of 15 degrees occurred after 60 minutes. At this point, the heatsink was removed and the temperature rise increased to 21 degrees. The aluminum heatsink with MX4 thermal compound appears to lower the steady-state operating temperature of the CIA by 6 degrees. The results for the copper heatsink show a temperature rise of 18 degrees after 60 minutes, followed by a further rise to 22 degrees after removing the heatsink. The copper heatsink appears to decrease the CIA chip's operating temperature by 3 degrees. When a heatsink is added, the time to reach operating temperature increases from 60 to 100 minutes from about 45 minutes. In both cases, it is possible that temperatures may still have increased by a degree or two on a long enough timeline, but I wanted to avoid leaving the computer on for hours at a time. This is important to keep in mind when conducting any future experiments. I would like to examine the effectiveness of the large aluminum heatsink on the VIC-2 chip. That is an experiment for the future.